The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hi, and welcome back to Element 14 Presents. Some time ago, I found this really cool sword at a thrift store, and I really liked the way it looked. Kind of looks like a piece of the aggro crag. So I decided to save it for a project in the future for some sort of hacking. And I think today is that day. It is time to see what I can do with this cool sword. So I think I'm gonna try to add some sort of effects. My main goal is to make it do things when I hack and slash. But I think adding some lights and sound is gonna be really fun. Let's do this.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
The main feature I want to have on my FX sword is to be able to have it do things when you move it specifically. So for that, I need an accelerometer. Previously, I have experimented with the BBC microbit, and it conveniently has one built in. So that's my accelerometer. It's a little big. It might be a little bit tricky to fit into the handle, but I think I can make it work. So I think I'm gonna start by seeing what kind of functionality I can get from the accelerometer in this microbit, and then see how I can potentially add sound and lights. All right, so the nice thing about the BBC microbit is that you don't have to know how to code to be able to program it. So I like using MakeCode and these blocks here. So I'm gonna see what options I have for my accelerometer. So there's this on shake block, and in here there's a bunch of different positions that you can place the microbit in and then have it do a thing. So it looks like, yeah, I think these will be useful. I can either program it with one of these positions, or it can also sense the amount of G-force that the microbit is experiencing. So that'll be useful. There's also this block here that measures the acceleration of the microbit. So it can measure in 3 different axes. And also I think strength is the measurement of the combination of those 3 axes. So, all right, I think I'm gonna write some code really quick and find some LEDs to plug into this to see what I can make it do. I'm gonna do a little bit of experimentation. All right, I took one of the sets of fairy lights I had lying around, cut off the battery pack, and I've got a female port here. So I can use this to plug into my microbit. Now it's got 10 LEDs on it, but they're not individually addressable. I'm pretty sure you can't do that. Yeah, no, you can't. So I'll be controlling all 10 of these at once. It'll be possible in the future for me to maybe use multiple strands, or maybe I'll try NeoPixels. I don't know. We'll see what we're gonna do. But for now, let's see what I can do with these lights using the accelerometer controls. So in MakeCode, I wrote 2 different blocks. So when the microbit gets tilted left, it'll do one thing, tilted right, it'll do another. I found that using the analog right pin block allows me to adjust the brightness of the LEDs. So I've got some little code in here that will dim or brighten the LEDs from 0 all the way up to the maximum 1023 in increments of 100 and at 2 different speeds depending on if I tilt it left or right. So let's see what that looks like. Okay, it's time for the sound effects. I have my microbit here hooked up to my little speaker, clipped to pin 0 and ground. Now, I did some research with the microbit and it doesn't have a whole lot of storage. In fact, I think it takes files that are only as big as 4 kilobytes. So I originally wanted to try to download some sound effects and load a bunch of different ones on there, like some pew pew, like some lasers or some like shoosh shoosh sword sound effects. but a lot of them were like 10 times that file size. So I don't think that was gonna work. So instead, I'm gonna see if I can make up some sound effects using the built-in music code that is part of MakeBlocks and the microbit. So to the code, let's see what I can come up with. Okay, to start, I need an input block. So I'm gonna grab just an on button pressed, because it's a little bit easier for me to test by being able to just push the buttons, but later I will use one of these blocks so I can use the accelerometer. So let's see under music what I got. I don't want to use any of the melodies because all of the melodies are weird and they're dumb. So instead, I'm gonna make it my own. So let's see, let's try play tone. Oh wait, there we go. All right, play tone. And let's see, let's start all the way up here. Boop. To make like solid pew pew noises, I need to have like a scale of notes that don't sound like boop boop boop. Doesn't sound like a beginning piano player. That's just like, and so I need really short notes. So I'm gonna go with my shortest note option, 1/16 beat. So if I press, oh wait, loading. If I press A over here, it's just like a little blip. All right, so I am going to add a bunch of those. I'm gonna have this scaled down. So I will duplicate this block and pick the next, go down to that B flat, A sharp, and we'll go right down to the next one. All right, I'm gonna create a descending scale and then we'll see how that sounds. Let's check out my descending sound effect. Oh, that's pretty good. Let's do another one. Let's duplicate whole thing. Except I want this one to start at, we're gonna start poop. Way down now, way down low. Coming up. Bringing it up, bringing it up. Switch this over to button press B. Let that baby load. See what that sounds like. All right. Ooh, whatcha? So if we go. Okay. I'm gonna see what other sound effects I can come up with, and then I'll see if I can combine it with my lights. Okay, I have my lights and my speaker hooked up to my microbit. So any music code on the microbit automatically comes out pin 0. So as you can see in my code, I have adjusted my lights to go to pin 1. So I've got my little fairy lights hooked up to P1, a little speaker hooked up to P0. And all right, I've got my music code and my lights. So let's see what happens if I throw those together. Let's put that one there. Yeah, I'm gonna put this one afterwards. Let's see what this does. All right, so if I tilt it left, it'll do like a little slow flash and get brighter. And then if I tilt right, it'll dim, and this is my ascending, and this is my descending sound. Okay, let's see what my microbit does. So if I tilt it right, oh, that's not ideal. That's problematic. So my current code has one happen before the other. So if I tilt it right, it plays the sound and then flashes the lights. If I tilt it left, it flashes the lights and then plays the sound. I don't want to have them happen at the same time, obviously. So let me mess around with the code, see what I can come up with. Okay, since I am not a programmer, I had to find some weird, super hacky way to make my code work. There's probably a more efficient way. So after I show you what I'm doing with my code, if you can find a more efficient way using code blocks, or I guess JavaScript, feel free to write that code and download it and post it on the Element 14 community, because I would love to see your solution. But I didn't want to spend like days and days and days trying to figure out how a way to make this work more efficiently. So I went with the fastest way I could come up with code. So what ended up working for me was originally my light dimming code had microsecond like delays or like pauses in there so that it would like hold each brightness level for like a fraction of a second before it dims, because otherwise it would just go and you wouldn't see any, the change of lights would not be visible to the naked eye. A 1/16 of a beat is about good for holding each light brightness. So I just interspersed them. So I have music note, brightness, music note, brightness, music note, brightness, and the 1/16 of a beat conveniently holds the brightness of my light just long enough so that the lights phase exactly at the speed I want, and the lights and sound are timed perfectly together. So I'll dump this to my microbit and show you what that looks like. Okay, so my lights and sound work simultaneously. I am happy with those FX. So I've got one for tilt left, tilt right. I might mess with that a little bit. I might come up with a few other fun little sound and lighting effects for different motions. We'll see what I can come up with, but I think it's time to figure out how to squeeze this all into the sword.
Hi, my name is James, and this is my electronics workbench. Together, we host Workbench Wednesdays. It is a show where I review electronics tools and equipment. Whether you are on a hobbyist budget or trying to equip a professional workstation, we've got you covered. Look for new episodes on Wednesdays and come connect with me at element14.com/Workbench Wednesdays.
All right, so sword handle. I have decided that I am going to use one of these foam squares to cut out the interior of my handle, and then use some thin like MDF that I have. It's like 0.1 inch or around 3 millimeters. So we'll have MDF on the outsides and foam in the middle. So the foam, I'm gonna need to carve out cavities for all my bits, like my micro bits and my speakers and my battery pack and a power switch that I want to be able to access from the outside so that I can save all my battery power. And then all of the lights will go up in the sword blade, so I don't have to worry so much about those, other than making sure that there is a path for all of the wires to get through. So if I use my foam, I can either etch a channel or use my Dremel to just like carve a path for those wires. So that should be pretty easy. It's easy to carve, so I'm gonna use that. Okay, so designing my handle shape. I took a picture of my sword blade because I'm gonna wanna match this curve here. All right, so I Photoshop magicked that, and I've got it in Illustrator, and I've got all my bits. So I went ahead and traced the outline of the sword blade. I gotta make sure that I can screw and sandwich all my handle pieces together. So here's a mock-up that I did of what the handle will look like. I need to be able to keep all of the layers sandwiched, so I need to add screw holes. So I had 2 on the outside of my handle, a couple right here. There's gonna be 2 more here that go through the blade. I need to have some down here in the bottom portion of the handle. So I need to make sure that those don't get in the way of any of the wires. Like I've got my wires here, kind of run down here. I went through a few different design iterations for the handles. So here you can see I had laser cut one like draft pattern, and found that like this was just too flimsy and not really stable enough. So I need to put more space between all of my parts. I'm gonna finalize that design, laser cut some prototypes, and hopefully it'll look good. So I've been playing around with my microbit a bit more and remembered that while it is a very handy feature that the microbit has these 3 inputs here that you can clip to, you can actually program to all of these little individual pads here. So there's a lot of pins available, and I want to take advantage of that. So I've got my schmancy breakout board thingy-do here for my microbit. New fancy lights. Oh yeah, individually addressable. Oh, now we got a cool laser effect. Pew pew. I've got 6 programmed right now. I might try to knock it up to 9. I did have some problems where some of the pins, the lights would be on when I didn't want them to be on. I think because of what else that pin controls on the board. So I'm gonna do some more experimentation and maybe make some more cool effects. Wire these up and glue them into the blade of my sword. We'll get it wired up. Okay, so I soldered up my sword and nothing worked. And of course, that's always that moment where you're just like, oh, come on, I tested everything, it should be fine. Okay, so what I discovered with the microbit is that, so previously with the microbit, I'd only ever really clipped on peripherals before, so like my speakers and all that, or I had this like pin out thing, and so I was always able to like directly connect to the pins. I soldered all the wires to the wrong side of the board. I didn't realize that the pads on the microbit are not, both sides are not connected to the I/O. So luckily I had been doing some testing and a couple of my wires were a little too close. One of them I'm putting like 2 on 1 pin, and so I tried soldering like alternating some on the front and some on the back, and then I discovered that only the lights on the one side that were soldered to the one side were working. So that was an interesting tidbit I learned about the microbit. So now I have everything soldered to the correct side of the board and everything's working fine. Yeah, let's button this up. I ended up settling on using 7 LEDs, with the top 2 attached to the same output pin on the BBC microbit. Each LED has a current limiting resistor. All the cathodes are tied together to ground, while each anode has a separate wire that leads to a different output pin on the microbit. The 2 speakers are wired in parallel, with one wire going to pin 0 and the other tied into the LED's ground wire. The battery pack wires are soldered directly to the power input pins on the microbit, with the positive lead first passing through a power switch. Let's take one final look at the code. So originally in make code, I was looking at the analog right pin block and trying to use it to like dim my lights so I could get like a cool burst. But that was back when I was using the fairy lights and I'm using individual LEDs. Well, this time when I tried that code, it got kind of buggy. So here what I had tried in this tilt right block here, I just did by 200 instead of my original by 100s and interspersed it. So if I tilt it right, which is actually left because my microbit is in the opposite orientation, you can see that it's a little buggy. They should all be turning on and like growing in brightness. And these 3 are fine, but these ones are kind of acting like they're just digital. Couldn't quite get it to work, so this is the code we have now. So for our final code, if the logo is down, which means the sword is up because our microbit's in there upside down, it goes like this. And we get this cool shoop shoop lasers out of the end of the sword. And then for logo up over here, 3 little beats, and it flashes. I have a nice little shake so that when you go, whatcha, get it intense, yeah.
that is my BBC microbit FX sword. I'm really happy with how it turned out. I'm glad I was able to put this power switch into the handle so that it's easily accessible by your just like pinky there. And I finally figured out how to lay out the board in the handle with the screws on the sides so that you can have access to reprogram it from the bottom like I had originally wanted. I'm really happy I can do that. So now I can play around with reprogramming this all I want. So if you were going to make a special FX prop using the capabilities of the BBC microbit, what would you do? Tell me about it on the Element 14 community. And if you want more details about this project, check the description below. See you next time.